Hello everyone. Welcome back to our video tutorial in probability and statistics. Today we're going to continue our discussion about finding the confidence interval specifically for a population proportion. A confidence interval estimate for a population proportion is a range of values that is likely to contain the true proportion of a certain characteristic or outcome within a population based on information obtained from a sample of that population. In simpler terms, imagine you want to know what proportion of people in a city prefer chocolate ice cream. Instead of surveying every single person in the city, you take a random sample and find that 60% of them prefer chocolate ice cream. However, you know that your sample might not perfectly represent the entire city population. A confidence interval gives you a range of values within which the true proportion of people in the city who prefer chocolate ice cream is likely to fall, along with a certain level of confidence. Here is the formula for proportion interval. P hat, or the sample proportion, plus or minus the z-value times the quantity of the square root of p hat times q hat divided by the sample size. Let's have an example. Suppose we conducted a survey to determine the proportion of customers who are satisfied with a certain product. Out of a random sample of 300 customers, 210 reported being satisfied. Let us now identify all the given values, starting with the sample size of 300. Then the sample proportion, or p hat, which is 210 divided by 300, is equal to 0.7. Next is the q hat, which is the complement of the sample proportion, whose formula is 1 minus p hat. So 1 minus 0.7 is 0.3. Therefore, the value of our q hat is 0.3. Next is the confidence level of 95%. Our alpha of 5%. Alpha over 2, which is 2.5%, or 0.025. To find the z-value, subtract 0.025 by 1, which gives us 0.975, then set aside 0.5. We have 0.475. Locate the area 0.475 to the z-table and find its corresponding z-value. So the z-value is 1.96. Now, since we already have all the values needed to find the confidence interval for population proportion, we can now substitute them to the formula. So we have the sample proportion, or p hat, of 0.7, plus or minus the z-value of 1.96 times the quantity of the square root of p hat times q hat, or 0.7 times 0.3 divided by the sample size of 300, which gives us 0.6481 for the lower limit and 0.7519 for the upper limit. So the 95% confidence interval estimate for the population proportion of satisfied customers is approximately 0.6481 up to 0.7519. This means we are 95% confident that the true proportion of all customers who are satisfied with the product lies within this interval. Let's have another example. Suppose we are conducting a survey to determine the proportion of people in a city who support a new public transportation initiative. Out of a random sample of 500 residents, 300 express support for the initiative. We want to calculate a 90% confidence interval for the proportion of all city residents who support the initiative. Let us now identify all the given values. For the sample size, we have 500, a confidence level of 90%, an alpha of 10% or 0.1010, a over 2 of 0.05, and for the z-value, we have 1.645. For the sample proportion, or p hat, 300 divided by 500 is 0.6, and for q hat, which is 10.6, is 0.4. Now, using the formula for the confidence interval for population proportion, let us find the value of margin or error, whose symbol is the uppercase letter E. The formula and find the margin of error can be seen in our formula of confidence interval, which is the z-value times the quantity of the square root of p hat times q hat divided by n. So the value of the margin of error is 0.036. Going back to our formula for the lower limit, the sample proportion, or p hat, is 0.6 minus the margin of error of 0.036, and for the upper limit we have 0.6 plus the 0.036, so we have 0.564 for the lower limit and 0.636 for the upper limit. Therefore, the 90% confidence interval for the proportion of all city residents who support the initiative is 0.564, 0.636, or from 56.4% up to 63.6%. Let's now have our quiz. Thank you for watching. I hope you have learned a lot from this video tutorial in probability and statistics. See you in the next video. Don't forget to like and follow for more.